Hi, this is a video about repairing the oil warning lights on a Yamaha outboard motor. I'm having a quite old motor from Yamaha, and that kind of a thing broke recently. It's basically used for indicating the amount of oil that I'm having in my motor. It's a two-stroke engine. So there are two different versions of it. One version is a 3 LED indication device, and it can be found on very low power motors up to 50-60 horsepower motors, and for the very small ones there is also a single LED version which just has one LED. I'm having that one here, and it's built into my dashboards. I will show you later how it looks like. And over 30 years of operation, those LEDs turned black, so they don't work anymore. For some of the lower power motors, this device is built directly into the motor, these indication lights here. So I asked Yamaha to get the spare part of that one. They said it's $400, which was way too expensive for a motor which is so old. So I said I would try to repair it myself, and it was actually quite easy, and I want to share it with you. So what does it include? It includes some kind of control box which has cables going back to the steering. I will explain you what those cables do, and then it has this harness with the 3 LEDs, red, yellow and green. So let's first of all see how the thing is working, so you understand how to test it. This is how it looks in my boat. So you're having here some kind of clock around, some kind of housing, and this is put into the dashboard. The control box is then also included in that one here. As I said, in some of the engines, this device is directly put inside the engine, and this control box is mounted on one of the sides. It's close to the oil container. And then there is a longer cable between the control box and the light unit. So how does it work? It's quite simple. You have this control box here, and then there are some cables to the warning lights, green, yellow and red, and it basically indicates how much oil you have in your oil tank, which is then diluting the petrol, which is put into the petrol with the oiling system. Inside that one there is an oil sensor which is having 2 switches, one high up and one low down, and there is some rod inside the oil sensor and some kind of floating device which is then floating on the surface of the oil. And if the tank is full with oil, the floating device will be high up, and we will be closing switch number 1, while the second switch here in portion 3, in the area 3, is still open. If you then use the engine and the oil gets used, the level will sink until the floating device is then in the second area, where both of those switches are open. And then when you're falling even lower on the level, this one will be open and number 3 will be closed. So there are 3 different states here. The first one is that the green wire coming from the control box over the switch will be connected to the minus pole of the battery. This is when you have a green light on. The green light is then lit. In the second area here, both of those switches will be open, which means that the green and the green-red wire coming from the control box will be open. They will be just hanging open, and then the yellow light will be turned. And when you drain even more of the oil, the third switch will be closed. The switch in the third area will be closed, while the upper switch will be still open, which basically means that the red-green cable will be connected to minus, while the green one is still hanging open, which means that the red light will be lit. Also there is the horn, alarm and horn cable here. If we're in the red state, this one will basically be pulled to the ground level, which will then honk the horn and will show the CDI box that it has to go down in rotation. So it will protect the motor. So if you're in that state, you will also see that there will be a 0 volt on the pink if you want to measure that one, if you want to check this functionality as well. So from the control box we're having those 5 cables here, the green and the red-green, which are fed by the signals from the sensor, which is basically either connected to minus, which is 0 volt, or hanging open, depending on what kind of fill level you have. And then you have the yellow one, which is the 12 volts, which is normally switched over your main power switch. And you have the black one, which is just the ground, which is the minus pole. So in case you wanted to test your assembly, the first thing you would do is you would take just a 12 volt battery or a DC supply, connect the yellow to the plus pole, the black one to the minus pole, and let the pink one just hang. And then once you do that, these ones will be both open, just let them hang out. You will see that the yellow should be lit, the other one should be dark, the other light should be dark. Then if you just take the green one and you attach this one to minus as well, and let the other one be open, you should see that the green one will be lit and the yellow one will be disappearing, so only the green one will be lit. If you take this with a red-green one, you put that one to minus and the other one is left loose, then you should see that the red one should illuminate. So that's very easy to test this box. If you do that and you see that the lights are not working, or some lights are not working, or they are very, the intensity is not good, then you might want to do the repair that I'm telling you now. So what I have been doing, this box here, I tried to get into the inside of the LED assembly here. And the same as the control box, this is all sealed with silicone. So in my case what I did, I took a scalpel and I just scratched out all the silicone that I could get, and then at the end I put some kind of metal piece here and I just pushed on the LEDs, and then eventually I was able to flip it out. I will show you. That's how it looked then. And then what you will find inside is a small circuit board with 3 LEDs on it, and in my case already 2 of the LEDs were just falling off because the legs of those were corroded. So over time there is some moisture coming in, and then there is a positive voltage on that one and a current, which means that the erosion will just keep going much faster and it will die eventually. And then you see there is a big fat cable coming in on that PCB, on that circuit board, and then there is a couple of other cables coming in. And from the cables you can't really figure how it is connected because there's so many cables. So I really opened it up and I could see and I could trace the copper traces here, and then in the end you will find something like this here. So first of all, if you just look at the thing from the front as you would see it, there is the red, there is the yellow, and there's the green one. These LEDs are having polarity. The anode, which is the plus pole of those diodes, is always on the lower side, on the round side of the plastic housing, and then when you have the cut side, this is the minus, so the plus is always down here. There are some small holes in the circuit board, which was allowing to fill up the whole device with the silicone. And then if you take it to the back side, if you turn it around, you would see how the cables are coming onto that PCB. There's a red one, a brown one, a white one, a black one, a green one, and a blue one. And there is also a fat black one coming in. And then with those small lines I indicate the connections there. So there is no electronic components on it. It's just copper connections on that circuit board. So basically the brown one is connecting to the plus of the red diode. The minus of the diode is going to the red. The white is going to the plus of the yellow one, where the small black one is going to the minus of the yellow one, is also connecting to the fat black one. And then you have the green one, which is basically the green to the plus of the green LED, and the blue going to the minus. So what you can do now, you can just cut the cables, rip all the internals out of the LED housing and just make those connections and put new LEDs in. Or you can do it as I did. I was really carefully taking the PCB, so the circuit board out, and I was then reusing it. So I put the new LEDs on. That it's 5mm LEDs, and take LEDs which have a better illumination strength, so that's something like the 1000 millicandela, 20 milliamps, 2 volts. These are standard LEDs that you can buy for cents. Put them in, put it back into the original housing, put some silicone in, like you use in bathrooms, just to seal it, and then go back and do the test procedure with just a regular 12-volt battery, or just plug it directly in. And when you have done it right, you should be able to get all those 3 lights working again without having to give $400 to Yamaha or buy some old crap on eBay, which is so old that it's most probably going to break any day. Good luck with it. Bye.